Hi there. There's been no shortage of lab projects using LoRaWAN, but it's time to move these low bitrate use cases into production. In this webinar, Kevin Holcomb shares some solid LoRaWAN use cases that are ready for production. Here's Kevin.
Okay, so we're going to go over LoRaWAN from a couple of different perspectives. The first thing we'll do is talk about, what is LoRaWAN? How does it work? What are the different components of the architecture? And then we'll go into some use cases specific to mining, right? And these will be use cases we've either seen implemented or that we've thought of. And I would love in the chat as we're going through this, if we show a use case where it's something you're like, oh, we don't need that, we've got that covered already. Or if you think of ones we don't present, please do mention those because that helps us as well on this side when we're building our products and solutions. And then finally, after we know what LoRaWAN is, and we go over some use cases, we'll show a way that Cisco has created that makes LoRaWAN a little easier to deploy, like a quick out of the box method to use LoRaWAN without the end user actually having to understand everything about LoRaWAN. Okay, so the first part is what is LoRaWAN? So it's an unlicensed spectrum, uses unlicensed spectrum, right? It'll be either the 800 or the 900 megahertz ISM band, depending on where you are in the world. And of course, it's unlicensed, it's scalable, it's really easy and low cost to do a deployment, right? You throw up a gateway, there's no licenses you have to get or getting regulatory bodies to give you access to spectrum or anything like that. It's just a pure ISM band. Long coverage, right? So you're going to get kilometers of coverage. Typically, rule of thumb, we'll usually say 15 kilometers in a rural environment. You go into a more dense urban environment, you're probably getting around 2, something like that, depending on lots of buildings and things to go through in that case. One gateway can literally cover, can handle thousands of sensors, right? So you get a lot of density of coverage there. Now, the thing with LoRaWAN is it's not for streaming video or file transfers or anything like that, right? It's really low bandwidth. It's for little pieces of information that happen every once in a while. So maybe I'm getting a temperature reading every 15 minutes, or I'm getting a vibration reading once an hour, or maybe a location piece of location data every 15 minutes. That's the kind of data we're looking at here. So, it's probably not really in your control network. It's probably more in your monitoring for the most part. Thinking of it in the perspective of a mining use case. And then the benefits you get from that low data rate, you get really low power consumption, right? So you got sensors out there that can be battery powered and can last, 10 years out there before the batteries need to be changed. So, you get your low data rate on one side. It's for a little piece of information, but the benefits you get is the long range and the long battery life. Okay, so Ian showed this very same slide, in the last presentations. He was covering the Wi-Fi and the BLE blocks here. And in this session, we'll be covering the LoRaWAN one down in the lower right there. So LoRaWAN, it kind of fills gaps. All wireless technologies have a place. They have a place where they shine, right? And then they have a place where maybe another technology is better than a given technology. So I like to think of LoRaWAN as kind of filling in some gaps from some other technologies. So, you're not going to get the high bandwidths of Wi-Fi or cellular, but you're going to get really long range and you're going to get long battery life, right? So LoRaWAN fits down there in the lower right of that diagram. Okay, as far as use cases, we'll show a couple in a few minutes that are specific to mining, but it's use cases for LoRaWAN are pretty broad, right? You can use it in manufacturing, mining, of course, smart cities, monitoring air quality, parking, all around a city, warehouse and logistics, ports, refineries, utilities. I mean, it's pretty wide, and there are sensors out there for just about everything you can think of. So that's where LoRaWAN, these are the kind of places that you would see LoRaWAN used, broadly speaking. We'll deep dive into a couple specific to mining in a few minutes, though. Okay, so Cisco has been in the LoRaWAN business for a long time. We were one of the initial members, right when LoRaWAN was first rolling out. So that was probably around 2015, 2016, somewhere around there. We're a founding member of the LoRa Alliance. That's the body that works to kind of standardize LoRaWAN and pretty broad global organization. So since the time when Cisco started with LoRaWAN, we've grown to over 500 customers in over 60 countries now. So we've got a lot of experience with deploying LoRaWAN. So we've been in it for a long time. Okay, so this is what your general LoRaWAN architecture looks like, right? In kind of a simplified form, right? So you have your endpoints, that's your sensors, right? They could be battery powered or they could be wired. It depends, right? And they're going to payload, they're going to measure, and they're going to encode the data, right? And then you got a gateway, and that's basically going to convert what comes over the air to IP. That's the main purpose of a gateway. And then you have the network server, which I would call the brain of the operation, right? So the LoRaWAN network, the network server is the brain. So it would be similar to like a wireless LAN controller and Wi-Fi, or maybe call manager for collaboration, right? So it's the device that's figured out, who can get on the network, which gateways can get on the network, which sensors can get on the network. It parts of the network server negotiate session keys, right? So the data that goes over there can be securely encrypted. It does deduplication because that's with LoRaWAN. LoRaWAN is a little different than Wi-Fi, whereas in Wi-Fi, I'll use like an 802.11, 2.4 gigahertz as an example. If you're walking through a building, you might have the first one on channel 1, the next AP on channel 6, and the next one on channel 11, right? And as you walk through the building, you're kind of hopping from one AP, going to the best AP. So with Wi-Fi, you'll typically set up all your gateways with the same channel plan. And so all the sensors that are out there, they're just putting out messages into the air. And any gateway that's around that can hear those messages will do so. And it will, because all the gateways are listening on the very same channels. They're going to forward that to the network server, and the network server figures out, I've seen this message already, right? So it does the deduplication in the network server. And then the network server can forward data out to your applications, right, for visualization or further analysis. So these are at a high level, this is the general architecture of LoRaWAN. And we'll go into each one of these in a little bit, a couple of slides here. Okay, so the first part we'll go to is for Cisco, we make some gateways, right? So we have the IXM gateway there on the right, or sorry, on the left. That's the IP67 outdoor rated gateway. And then we have a new product that's just coming out imminently, and that's a pluggable module for our IR1101 router. Right, so the IR1101 is fully modular, and we'll have a pluggable module now that you can plug inside that, turn that router into a LoRaWAN gateway. So a little deeper dive on each one of those products. So for the gateway, we typically see it mounted on poles or on rooftops. We call this one the IXM. It's very rugged, IP67. You can do dual antennas for receive diversity if you want to do that, and that one, we do see it sometimes indoors as well. If you're in like a harsh industrial type of environment, we'll also see this one indoors. But definitely pole top, rooftop, towers. It's a great gateway for that. And then the 1101 PIM, the pluggable module, that's it's a little module that'll actually plug into the 1101. So the nice thing about this is the 1101 also has a family of cellular modules you can plug in. So now you can take this single box here and you can do a cellular backhaul right there from this same device. You can plug the LoRaWAN pluggable module in. So now you've got LoRaWAN going out, you got cellular backhaul, and then you can also host applications on it, right? So you can run small applications on all on the same device there. And that's fully rugged as well. That's a DIN rail mount device. So you typically have that inside a cabinet. Depending on how harsh the environment is, you'd have that, mounted inside a cabinet. Then you'd have the antenna, outside the cabinet for your LoRaWAN. Okay, now the piece we didn't cover yet is the network server piece. So when it comes to the network server, remember the network server is the brain of a LoRaWAN network, right? So for the network server, Cisco's we resell a network server from a company called Actility. They call it ThingPark Enterprise. So we resell that. We also support something we call Common Packet Forwarder. which allows the gateway to interoperate with a lot of other network server vendors that are on the market as well. Okay, so that would be, if you're doing I call it the build your own approach, where, thinking back to that diagram we looked at a few minutes ago, you pick your own sensors, you pick your gateway, hopefully a Cisco gateway, you pick your own network server, and you pick your own applications, right? And you put all this together. So that's one way to consume LoRaWAN. That's one way to implement it. And then in a few more slides after this, I'm going to show you something that we've done here at Cisco where we kind of put all of that diagram that we saw earlier with those 4 different pieces. We put that all under the Cisco umbrella and kind of take out some of the complexity and what I would call a science project out of LoRaWAN deployments. Okay, so let's think about some use cases specific to mining. So one big one we've seen implemented before and thought about even more is asset tracking, right? So just general asset tracking. So tracking things like light plants or comms trailer, right? Like if you have a comms trailer, maybe it has to be powered down to be moved, to be relocated. And, maybe when it gets relocated, somebody forgets to turn the power back on and now you can't find it, right? So even though the comms trailer probably does have GPS on it natively, if the power's not there, maybe you can't locate it, right? So it's kind of a nice out of band way. Just throw a little sensor on there, throw a gateway or 2 up around the mine, and now you can know where your comms trailers are. Same power skids, you could track some service vehicles or safety trucks, restroom facilities, right? If you have those scattered around a site and might misplace them sometimes, now you throw a little sensor in there. Usually they make GPS sensors for LoRaWAN. So it's GPS on one side, gets a fix from the satellites, backhauls that over LoRaWAN, right? So you can get those. And then just general theft prevention, right? You can draw geofences and you can know if something moved outside the geofence, or you can even be notified if it moves at all. Like maybe you have something that's not supposed to move. And if somebody tries to move it, you want a notification that it's been moved. Another good one is, air quality monitoring. And again, let us know in the chat. I see a couple ideas there coming in. If there's other things, in these categories that we missed or other things you can think of, please do let us know. So another one we've seen implemented is air quality monitoring, right? So that could be, particulate matter, SO2, CO2, and that could be done for a number of reasons. It could be regulatory compliance. It could be, proof so that you can get tax incentives, and also, for worker safety, right? Just making the mine a safer place to work. Another one is cable management, right? So this particular sensor is made by Pygo, and it's used to manage the location of trailing cables, right? And to monitor those for not just location, but also for shock and, the energy status. So is current going through this wire or not? So that's another good use case. And again, you throw up a couple of LoRaWAN gateways and you've covered this entire gigantic space. Vibration monitoring, right? So maybe if I know a lot of conveyor systems already have built-in monitoring, but maybe you have a legacy conveyor system that doesn't have built-in vibration monitoring, or also just miscellaneous pumps and motors that are around, right? So you can do things with LoRaWAN, like you can have a smart vibration sensor out there that periodically takes measurements and reports those back, right? And then you can try to do preventative maintenance or know when a failure is going to happen before it actually happens and impacts production. Okay, and this is a good catch-all, like physical security. Just maybe you have an out building or something, or a storage building for supplies closer to the service area, right? Those kind of buildings that may have power, but you may not have a security system, maybe, or you got a building, maybe a comms building, and the door gets left open somehow, and bad things can happen. Animals can come in, the weather can come in, so you could get notification of things like that happening. It could be access to battery compartments on skids or trailers. You could just general door open, close, or occupancy. You want to know if somebody came into a building. Maybe people are normally not supposed to be there, right? So those are just general physical security use cases. And in the picture here, you can also see that tank out to the side. LoRaWAN, there's also tank sensors right? So you can monitor tank level as well over, pretty far range. Okay, so now we've kind of seen what LoRaWAN is and, some use cases around of mine. I'm going to show you something. This is what I alluded to earlier, where that diagram we had a couple back in the beginning where we showed the architecture. This is all of that diagram under one umbrella, right? So we call this Cisco Industrial Asset Vision, and that's where we have sensors they're Cisco sensors. You have our gateway, and then there's a cloud managed application. So there's nothing to install on-prem. I know that may not work everywhere, right? The fact that it's cloud, but for places where it does work, you have this cloud managed dashboard. So everything, you don't have to install any servers. When we push new features down, you don't have to install anything, or it's the new features just magically appear. So that's the real goal of it, is to make it so that the way we looked at it with Asset Vision is the customer has assets, and the customer wants data about those assets. And they don't really want to have to be an expert on LoRaWAN. We don't want to have to get console cables out. None of that. It's just like, I've got stuff. I want to monitor my stuff. What's the fastest way I can do that, right? And how do I maintain it at scale once I've got lots of sensors out there? So we do use LoRaWAN. Our sensors use LoRaWAN, but we try to craft the solution offering in such a way that you don't necessarily have to be an expert on LoRaWAN. In fact, that network server piece, that's the brain of a LoRaWAN network, you never interface with that. That's all abstracted away. And so when you do things like onboard sensors, it's all based on a mobile device. You scan a QR code, and that's it. Scan a QR code, turn the sensor on, it's reporting data. So, looking at the cloud side, the main advantages of this are you have single pane of glass. Look at all your assets and locations. And we have some simple reporting, flexible alerting, so you can draw geofences. You can be alerted when something leaves a geofence. If your temperature goes too high, your vibration gets too high, anything like that, you can be alerted through email and on a mobile. And we also have role-based access. So if you, I'll show you in a second. I'll actually show what that looks like in the actual dashboard. Okay, so everything deploys in minutes, and that goes for the gateway itself all the way to the sensors. So as I mentioned earlier, it's all based on a scan with a mobile device. So even the gateways. So you scan a barcode on the back of the gateway. As long as the gateway can reach the cloud, the ports are open and everything, the right configuration gets pushed down automatically. Same for sensors. We ship the sensors. Most of our sensors are battery powered, with one exception, and all those that are battery powered ship with the batteries installed. So it's literally like you pull a new sensor out of the box, you onboard it, you got data flowing in about 30 seconds. And the other beauty of this is the data doesn't have to stay within Asset Vision. We can publish the data out through MQTT, for instance, or Azure IoT Hub, and then you can pull it into your existing workflow or business applications. Okay, I wanted to deep dive on the next two sensors in particular. So today we have 12 sensors. I'll show you more about those in a minute, but there are two in particular that are new that I think have more applicability to mining. So the first one is the AV400, and we call that the Industrial Sensor Bridge. So the idea with this is we know that there are a lot of industrial sensors out there that Cisco would never make, right? So pressurized steam pipe, if you want to monitor that, or you want to monitor the tank level of some corrosive material, like Cisco, that's not really our business, right? So we're not going to make those kind of sensors. But there are vendors out there that make those very specialized sensors. And a lot of times they're running 4 to 20 milliamps or 1 to 5 volts, something like that. And so our idea was, we'll make it easy now to get that data in, right? So you can use the sensors, the third-party sensors that you already own, 4 to 20, 0 to 10, whatever it might be. And now you connect those into our bridge. And now periodically, 15 minutes by default, we're going to sample those, and we backhaul that over LoRaWAN. So now you can get remote visibility into that data. So we have 4 analog inputs on the device, 2 for 4 to 20 milliamps, and then we have 2 that are set up for voltage. And then there are 2 digital inputs. So anything that like a wet or dry contact closure, those types of events, you can monitor those with the digital input, and we can get remote access to that. This is the one earlier when I mentioned they're all battery powered. This is the one exception. So this one, because we know the 4 to 20 milliamp loop, for instance, or those external sensors, they're going to be powered anyway by something. So we just let this also be powered by that same power source, right? So this one you put out in the field, you never have to worry about batteries because presumably there's a power source there anyway. So let's go ahead and use that. It's industrial rated. This one's IP66, a wide operating temp. And this one has an external antenna. This is the only sensor we have. All the others are internal antennas, but this one has the external antenna. That's in case you put it inside a cabinet or something. It makes it easy to get the antenna out. So that one we feel like will open up a lot of use cases because there's 4 to 20 milliamp sensors for everything. And then the other new one is the AV251. That is a vibration sensor. So these we report on per axis, XYZ, right? We can do acceleration RMS and peak. We can do velocity RMS, displacement, and several statistical derivations. Now, the cool thing about this sensor is, because remember, LoRaWAN is for small payloads, right? It's really low bandwidth. But vibration monitoring is actually quite complex, right? You're going to wake up and you're going to take a lot of measurements in the time domain, and then you have to convert that to something that is suitable to go over LoRaWAN, right? So you're not going to, like, if we wake up and take 800 samples in the time domain per axis, we wouldn't be able to send all 2,400 samples all over the air on LoRaWAN. So there's edge processing that happens inside this sensor and calculates all of those. Some of these are in the frequency domain, right? It's gonna do the conversions, and it reports just this summary data over LoRaWAN. So now when it gets to you in the cloud, you can start to look at, what's normal for this sensor. It's usually maybe the velocity RMS is normally at a certain level, and all of a sudden it gets higher than that, right? You can do it that way and get an alert. Another way to look at it is, there's ISO specs out there that specify if you have this horsepower of machine mounted in this way, the velocity RMS should not be higher than this, right? There's different zones. There's like the green zone, everything's okay. There's a yellow zone where it's like, okay, you can still run this machine, but go check on it when you get a chance. And then there's a red zone where it's like, don't even operate this machine anymore, right? So you can also do, that would be an even simpler way of doing monitoring. It's just knowing what you put that sensor on and setting those firm thresholds there, based on an ISO spec. So another cool thing about this, it has a temperature sensor in the base, right? So you can pick up those kind of machine failures, like a lubricant gets old or it's gone and the machine starts to heat up, or, bearing gets damaged and it's causing friction and causes heat. We also have a magnetic base for this sensor. So we have a couple ways to mount it. One is you can use epoxy. Another way is just a stud mount if there happens to be a hole, the corresponding hole in the machine. And the other way is just the magnet mount. So it's a pretty strong magnet, and you can put the magnet mount on the bottom of the sensor, and as long as the motor is ferromagnetic, you can attach it that way. So that's another new sensor that we have. And let me for a few minutes here, I'll show you the actual dashboard. Okay, so one other thing I should mention before I forget, the sensors that we sell, that Cisco sells with industrial asset vision, are only for industrial asset vision. So we don't sell those for use outside of industrial asset vision. Like if you wanted to use it, for instance, with just generic LoRaWAN, kind of the build your own solution, we don't sell it in that way. So because industrial asset vision is kind of a curated solution, full stack solution. So it's our sensors, our gateway, and our cloud app all working together, right? So a couple of things I mentioned earlier, I would show the role-based access control, right? So you can create in here in the cloud, you can create these different levels of your hierarchy, depending however you want to. It could be geographical, it could be based on business role, anything. You can create that how you want, and then you can create what's called an access control group, and you can put certain people or certain groups of people in the access control group, and they only have access to certain levels of the hierarchy, right? So you can kind of control who can see what through here as well. And then I won't go too deep into it, but I'll show you a couple of the high points. So, some things that might apply to mining, the location. So we have a sensor that is a GPS location sensor. It's this one right here, the AV300, right? So that's going to monitor, it just looks for GPS, right? It looks for the satellites, periodically derives a GPS fix and uplinks that over LoRaWAN. And if we want to see how that might look, let's look at assets. Let's go down here to field assets. We've got a truck out there. And let's see what the location of that truck is. So we can go into tracking. And now we can see where the truck is, right? You can see a little breadcrumb trail of where that truck has been. So we can do that kind of thing. The other one that's a nice sensor to look at, I'll show you that vibration sensor, the kind of data that comes off of that. So if we've got, I think it's under facilities. Yeah, so on the roof of one of the Cisco buildings, we've got a chiller pump. And so we've had a vibration sensor up there for almost a year now. And so here's all the kinds of data you can get off of that. So you can see velocity, RMS, acceleration peak per axis, right? You're seeing it in all axes. And then you get all those statistical derivations down here, right? Crest factor, kurtosis, and skewness, and deviation. You can get all that as well. Now, let's say you wanted that data, you wanted to export that data because you wanted to show it to somebody else, or maybe somebody who's not an Asset Vision user. You can get that as well. You can get it in a tabular form, right? So you can also get the data in a tabular form there, and you can export it to a CSV. And then the other sensor I'll show you is the 4 to 20 milliamp bridge. So if we go back to our hierarchy, I have a bridge here. So that's the bridge device. And I'll show you something cool we did. So 4 to 20 milliamp sensor, 4 milliamps will mean something and 20 milliamps means something, right? Like it wouldn't be very useful to tell somebody 7.6 milliamps. They're like, what does that mean, right? What's the tank level? What's the temperature? What does 7.6 mean? So what we do here is when you create one of these sensors, I'm going to delete this one, and I'll show you what it looks like if we add a new one for air quality. So you actually put the transformation in Asset Vision. So you can put, what does 4 milliamps mean? What does 20 milliamps mean? And when Asset Vision shows you that data, like for instance, if we had a furnace temperature, like we have temperature sensors in Asset Vision, but they don't go to like the temperature of a furnace. Right. So you might use a 4 to 20 milliamp sensor, and you're going up to like 1,000 degrees. And so here you'll see the actual temperature, right? And this hasn't changed very much. This is an emulator, but I haven't moved the dial in a while. But so that you actually get the real data, the actionable data that you can do something with, right? And not 7.6 milliamps. Now we do show you that if you wanted to see it in tabular form. There's the raw data. In this case, it's 13.5 milliamps. It translates to 716.45 Fahrenheit in this case. If we look back at the way that you do this, that you set up this transformation. So let's go to inputs. Let's take this analog input 4, which is a voltage device. And let's say that we're going to make this an air quality. We're going to monitor air quality with this. So we'll just call it air quality. We know this is a voltage input because remember the device physically has 2 current inputs and 2 voltage inputs. So let's say it's air quality. So the output unit is going to be probably concentration. So let's say it's parts per million, something like that. We'll say, okay, if I see 0 volts, just for fun, let's make this a 1 to 5 volt sensor. So 1 volt might mean 0 parts per million, and maybe 5 volts means, let's say 130 parts per million. And we can either assign that to an asset, or we can just put it in the organization hierarchy somewhere. So in this case, I'm going to drop it under the bridge demo area of the org hierarchy, and we do add. And so when I come back here now, I can see, oh, there's my transform I just created. 1 volt means 0 parts per million, 5 volts is 130. And now whenever this actually starts to report, you get the real actionable data, right, that you can actually act on and not have to do the translation. So the other part I'll leave.
Yeah, Kevin, there's a couple of questions that came up that I'm wondering if we need to talk to with the group. Is there alarming that you can create directly out of this, and who do you notify? See an alert section there.
There is. So you can create alarms. So you can go into alerts. You can create these rules, right? So in this case, I've got different things like the motor vibration too high. And then you can look in, so you can create in the alert. The way we did it is an alert is just a rule that stands by itself. It doesn't notify anybody on its own. It's just
Okay.
a statement, right? It's like vibration too high or temperature too high and a threshold. That's all it does natively by itself. But what you do is you create a template. And now when you get into the template is where you say, here's the rule that I want to attach, and here's all the people that I want to notify. And you can even put multiple rules.
Okay.
Yeah, you can do multiple rules because you can do like an escalation path where like maybe if the temperature gets to this level, I notify somebody. If it keeps rising more, I notify somebody else, right? And the benefit of that is when you go out to install that device with the mobile app, you don't have to remember all the rules. You don't have to remember who gets notified and which way. Is it email? Is it SMS? You just remember, oh, when I install a sensor on this type of motor, I'm always supposed to use this template. And all of that information magically gets pushed to the sensor. Yeah, so that's how we create the alerts.
Hope you enjoyed this presentation from Kevin. For more information on Cisco and the mining industry, check out cisco.com/go/mining. Take care.